Welcome to Algorithm Visualized. This is Golden Sun. Today is June 21st, 2022. Okay, let's get started. So first of all, let me share with you a variation of Tower of Hanoi, the famous toy or tool in recursive thinking and teaching. So here, let me bring up a whiteboard. Auto draw, my favorite whiteboard. Okay. So for those who don't know what is Tower of Hanoi, it's a very simple toy like that. So let me draw a base. And oh, not good enough. Okay, and the 3 packs: left, middle, and the right. And say we have a pile of discs, a pile of discs like that. Okay, so the rule says we cannot put a larger disk on any smaller ones. Okay, so let me put 4 of them. It can be n. Legend says we have 64 of them. So just to keep it simple, right? We put 4 disks here. The standard Tower of Hanoi says, okay, Tower of Hanoi, right? Each time we can move only 1 disk from 1 pack to the other, any other, like that, here or here, as long as we don't put a bigger one on the top of the smaller one. So yeah, for example, we want to move all the 4, right, disks to the rightmost pack. So we'll do something like that. Oh, no. 1, 2, okay, drag, put it, this one here maybe, and this one here, and that one here. Hopefully, so this one cannot be put here, it can be put here. What's next? I want to move these 2 to this pack, so we can move the largest one to the middle. So I have to do that without breaking the rule, right? And this one can go here. Yeah, now I can move this one to here. So, and this one put here. No, I can put it here. Oh, yeah, better to put it here. So I can do that. And then this one, yeah, most of you, I guess, already are already familiar with this one. So here, and you see, so I just finished moving, right, the whole thing to the middle. So in the same algorithm or same way, right, we can move it to the right. Yeah, to save some time, I just stop here. And that is not important here. The important is we want to build some arithmetic thinking. Okay, here it will be recursive thinking. What is the recursive thinking? So, okay, let's put it back. Let me undo. Command Z for undo. Okay, so what is the magic recursive thinking, right? So we have a base case. So what if we have only 1, right? Delete. Let's put just 1, right? With only 1 disk, we can move it anywhere, right, without breaking the code. So we can call that the base case. Okay, now let me put it back. Okay, now with the base case ready, we can make a recursive assumption, recursive hypothesis, right? We can assume this one. I can hold on Command key to select them. Yeah, we can assume under some magic, with some magic power, we can move this one to anywhere. Okay, so now we move this one. Is a similar problem but with a smaller scale, right? We want to move 4. We assume we can do 4 minus 1. We can do 3 of them. Now, this is the base case. We move it here. Then again, recursively, we can move n minus 1, which is 3. We can move 3 of them. Right, from the middle peg to the right, and done. Yeah, this is the standard classic Tower of Hanoi. Now let me add adjacent, right? Adjacent Tower of Hanoi. This is a small variation of the standard one. It means the actual constraint is we cannot jump from this peg to that. It has to be moved to its neighbor only, right? For example, here is okay, and from here, and to here is also okay, but we cannot like jump. So now how can we do that? Let's try 2 of them. Okay, delete that. So for example, we want to move the 2 disks from the rightmost peg to the leftmost. Okay, so we can do this one here, and of course we cannot put the larger one over the smaller one, right? This one is still here. And then we can move this one to here. Okay, now we put this guy here. And right? Be careful, we cannot just put this one here because this is adjacent the Tower of Hanoi problem. We have to do, right? We can only move it to its neighbor here. Oh, good. We can do that. Oh, sorry about that. So we can put it here without breaking the adjacent Tower of Hanoi rule. Then we can do this. And then we can do that. And again here. So we move the 2 of them successfully here. Now what is the recursive thinking about this job, right? To move 4 disks from the rightmost peg to the leftmost peg using adjacent Tower of Hanoi rule. So we already know the base case works, right? We can move 1 from here to here and there, right? 2 steps. Now, what is the recursive thinking? We can assume we can move, right? 3 of them successfully. So now we can put this one here. And keep going. We put this one here. And then this goes here. Okay, again, recursive thinking. Oh, no. We need select 1 by 1. Here, here, and this one. We move it to the middle and again to here. Now we can move the largest one to the destination. Okay. We need to use the recursive solution again, right? the same problem but with a smaller scale. 3 of them we can move here to here and here. Done. Right? It's like a magic. Okay, now what is the visualized, right? This series of videos is called algorithm visualized. Okay, let me show you my idea. So let's bring up the Xcode. So we'll write the code to visualize the Tower of Hanoi. Okay, so run it. It will bring up the simulator, my favorite iPad Pro 9.7 inch simulator. Yeah, it takes a while. Okay, so the 3 packs, right? So we have solutions, demonstrations. It's not demonstration. We'll write the real code from scratch for this one if you have a Apple computer. Otherwise, we'll do, right, Java or Python in terminal, right? So Tower of Hanoi. Cool, right? So this is the standard Tower of Hanoi. Okay, let's stop it and try adjacent Tower of Hanoi. Yeah, you see, each move follows the new constraint of adjacent Tower of Hanoi. Yeah, okay, let's stop it. So if we can do that, it's cool, right? But if you don't want to do it, or you don't have a Apple computer, we can bring up our terminal. So it's like command, the pure text-based window, right? It's we have that in Windows computer and the Apple computer and any other computer. So where we are, okay, so I'll go to there, and this is my Tower of Hanoi Java code, like that, and we can run it using we can compile, right? Java C Tower of Hanoi, and I'll run it using Java. The class name is TOHAPP. Okay, so there are only 3 disks. Done, right? Animated. Cool. And oh, by the way, I'm using this computer, Mac OS Monterey version 12.4. Okay, great. So in the next video, we'll start writing code. See you then. Thank you for watching. Bye.